At AP Review, this is 2014 AB Free Response 2. Let R be the region enclosed by the graph of, oh, and they did call this one f of x, that was so nice of them, by f of x, which is this x to the fourth minus 2.3 x to the third plus 4, and the line y equals 4, as shown in this figure, but also much better on the real AP. So I called this f of x my y1 in my calculator, and I called the 4 my y2. Just worth noting, because you're going to go ahead and put them in a calculator since this is a calculator section. Find the volume of the solid generated when R is rotated about the horizontal line y equals -2. Okay, cool. So, wow, they jumped right in and gave you something hard. Okay. So, well, if that's 4, right? Sorry, just for argument's sake. -2 somewhere around here, right? So what they're saying is you're going to take this shape and you're going to revolve this little teeny slice around this axis of rotation, and what you're going to get is an annulus, right? Which is sort of like a two-dimensional donut, right? So we call them washers a lot, right? But basically, when you're finding the area of a shape that looks like this, right? When you're finding an area of a shape that looks like this, it's the big outer circle, if you found that area, minus the hole that you cut out, right? So it's pi big radius squared minus pi little radius squared, or pi big radius squared minus little radius squared in parentheses, right? You're not squaring the whole quantity, you're squaring them individually. Cool. So really the task at hand for us, since this is a calculator problem, is to make sure that we write the integrand correctly using this formula. So the big radius is going to be the top curve minus the bottom curve. So the big radius in this problem is a 4 minus a -2. Now you can leave it as a 4 minus -2, or you can make it a 6. It doesn't really matter. Or you can make it a 4 plus 2. It doesn't really matter. So my little radius is going to be this curve, right, which was f of x, minus the -2, but because they called it f of x, which is why I was kind of stoked when I noticed that, I can call it f of x plus 2. So the integrand I want to set up for my part A is that the volume is the integral from, oh, well, that's a good point. I should probably notice where they intersect. They definitely intersect at 0, but we need this point of intersection. So before I figure that out, I really need to figure out what this point is. So I need to find the bound, which is usually the first thing I do, but sometimes my brain checks out a little bit. So I have my y1. I want to know when it equals my y2, so I'm going to do second calc intersect. Right, so that's second calc, and then 5. So second, so here's my graph, right? Second calc, and I pick 5, which is intersect, and I want to scroll to the intersect. Now, they do intersect at 0, and you can see that by visual inspection. Oh, wait, I went too far. My bad. All right, so wait, there we go. All right, here we go. Okay, so there I am. I'm to the left. I'm close enough to the middle. Great. Okay, I hit enter, and I get 2.3, right? It's just a straight up 2.3. It's not anything that's rounded. It is actually 2.3. So if you want, you could call it something else, but it would be weird. So I'm going to integrate from 0 to 2.3 of pi big R squared. So that's going to be 4 plus 2 quantity squared minus little r squared, which is f of x plus 2 quantity squared with respect to x. This is what the AP needs to see, and then it's your job to find the numerical value that goes with it, right? But you actually get way more points for setting up this integrand than you get for the actual value. So if I quit out of this, I'm going to get a pi, right? Math 9, right? So, oh, sorry, I'll write it down for you too. So I'm going to type pi. Math 9 is function integrate of, now, this was what I called y2 plus 2, right? So y2 plus 2, quantity squared, minus y1 plus 2, quantity squared, with respect to x, from 0 to 2.3, right? So that's what I'm going to type in my calculator. So now, if you don't want to use y2 as y2, like y2 was a 4. If you just want to call it a 4, that's fine. But for consistency's sake, I'm going to actually call it a y2, minus, in parentheses, vars over to y vars function y1 plus 2, close parentheses, squared, comma, with respect to x, from 0 to 2.3. So even though like the AP doesn't explicitly test calculator skills, if you don't know how to put this in a calculator, you're going to get a part of the problem wrong. So the answer you want to get is 98.867 or 8, depending on if you round or truncate. So again, the AP only wants to see this setup completely right and this answer, but you have to know how to put it in your calculator. Cool. Part B. Region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. Good times. All right, so Try not to completely wreck my diagram. So for part B, so ignore all the red nonsense. Okay, so part B, so perpendicular to the x-axis in this base R are isosceles right triangles where one leg is here and then the other leg would be up here, right? So let's look at what one of these cross sections look like. They are an isosceles right triangle where whatever this base is, this is also the same base because that's what makes them an isosceles right triangle. So the area of this thing is 1/2 base times height, or just 1/2 base squared, right? But the base of this triangle is going to be top curve minus bottom curve. So the base of this triangle is going to be the top curve, which is 4, minus the bottom curve, which is f of x, meaning that the area of one of these triangles somewhere in this thing is 1/2 the quantity 4 minus f of x whole thing squared, right? Well, the volume is if you just add up all the triangles. So my answer to B is going to be that I want to integrate from 0 to 2.3 of all of the triangles, which is going to be a 1/2 4 minus f of x whole quantity squared with respect to x. So that's what the AP needs to see, and then again, they just want you to be able to integrate it, right? So you're going to type it in your calculator, right? When you type it in, I'm probably going to put the 0.5 in front because I'm kind of lazy. 0.5 function integrate of so again, if you want to call it 4, you can. You can also notice that this was your y1 and this was your y2, right? So in parentheses, y1 minus y2 quantity squared with respect to x from 0 to 2.3, right? Honestly, you could probably second enter and change this a little bit. So if I hit second enter, I already have most of those values that I want. So I'm going to delete the pi at the front and put a 0.5 instead, right? I wanted a y1 minus y2. I'm just going to work my way down here till I get to that y1. Oh, I'm sorry, I wanted that's y2 minus y1, right? That's my order, my bad. That was my y2 minus my y1 if I note my own notation up there. Not that it really matters because you're squaring it anyway, but it was my y2 minus my y1. So, so I want y2 minus y1 quantity squared with respect to x from 0 to 2.3, right? So I double check. I have the 0.5. I have y2 minus y1 quantity squared with respect to x from 0 to 2.3, and I hit enter, and I get the 3.574 or 3.573, depending on if you round or truncate. So 3.574 or 573. And again, the AP doesn't care about this at all, but you have to know how to put it in your calculator. Last one, part C. The vertical line, x equals k. So let's clean up my tragic diagram a little bit. The vertical line, x equals k, divides R into two regions with equal areas, right? But do not solve an equation involving integral expressions that should give the value of k. All right, so the trick here is what they're saying is somewhere in the middle here. So somewhere in the middle here, there's some k such that this region is equal to this region, right? So really, the easiest way to do this is to just write an integral for the left half and write an integral for the right half and say that they have to be equal. So we already know, so the area of R should be top minus bottom from 0 to 2.3. But the area of region 1 should be the integral from 0 to k of the top curve, which is 4, minus the bottom curve, which is f of x. So this should be the left half, right? So this is the left half, that 1. That should equal the integral from k to 2.3 of the 4 minus f of x with respect to x, because this would be the right half. Now, there are other ways to do this. I've seen people do it where they say the integral from 0 to k should be double of the integral from 0 to 2.3 of the same thing, and that's fine. Or sorry, not double, should be half, right? The integral from 0 to k should be 1/2 of the integral from 0 to 2.3, and that's fine. I think this is the easier way to do it, is just to say left half equals right half, and then you're done.